So, yeah, hello everybody. Nice to see so much people here this early. So, you all survived yesterday night. That's a good sign. Okay, hello again. I'm Daniel, and I will talk a little bit about this camera in front, obviously. That's why you're all here, because of the cool camera, isn't it? So, yeah, okay, we will go through the agenda for a short moment. So I got a little introduction. Why are we into this topic? What's the reason? Where is the security coming into play? Then I had a look at the specific network interfaces of this camera. So first we got through the transport protocols. Afterwards, I will say a word or twice on the communication modes of the cameras and specific attacks against those communication modes. In the end, there will be some conclusions, but we will get to this really soon. Okay, so Canon recently put out a series of high-end DSLR cameras with network-enabled interfaces. So we did some research on those cameras, and I tried to point out all the security flaws involved and reasonable attack paths against those security flaws. So I'm speaking about the Canon flagship camera, which is the 1DX you see in front here. And yeah, that's the camera again. It's not that big, real, but it's quite heavy. So, and Canon USA got some really nice marketing. They say, okay, we now got a built-in Ethernet port that allows fast and easy transfer of images directly to the cloud. Also, there is a wireless interface on this camera, so you can even upload the images to the cloud from any hotspot around the world. So isn't that amazing? Yeah, as you see, this camera got a real Ethernet port on the side, and that was one of the main reasons for looking into this camera, getting into all the protocols and stuff, and look if Canon did a good job in kind of implementing the network interfaces. So, as I said, there is also a wireless interface available for the camera. It comes in form of a little adapter. You have to screw it on with some proprietary connection, and it's all really expensive stuff, so only for pro photographers. Or the ones with too much money. Yeah, actually it's a nice toy, but is it secure is the question. So who is the target? Who is concerned about security reasons with those kind of cameras? Yeah, it's mainly the target, aka Mr. Reuters. As you see, they're using a bunch of those cameras and standing there in crowds just taking some photos. And yeah, believe me, like photojournalists really love the feature of the network interface and the Wi-Fi connection, because they can instantly review the pictures on the iPad and just push some screens and upload it to wherever the images are supposed to go. So it's really nice in case of the image flow. So yeah. It's also nice in some other cases, but we will see that. Okay, what could possibly go wrong if we're able to get the real unedited footage first, so download all the uncensored pictures from the camera directly from the event? Or what would happen if we were able to upload some images to the camera? Like put on some bad images you don't want to have on your camera and then point out the photographer to some security guy. So, hey, he got really bad images. You should take a look at that camera. Or even worse, what happens if we're able to turn the camera in a surveillance device? Okay, so we'll get onto this. First, we had the underlying transport protocols, which is obviously you got some layer 2 connection, the Ethernet or the WaveLAN. It's a standard Ethernet port, and also it's standard wireless LAN. There's nothing special about that. The communication modes all use standard TCP/IP. by which I mean IPv4. There is no IPv6 camera on the support on the camera yet. But yeah, I don't think they will get any IPv6 support in the near future. Okay, so speaking about traditional attacks, we first had a look on layer 2 of the camera, which means like all the spooky Ethernet stuff one could do, which means like ARP spoofing. This is possible on the camera, so the camera doesn't hold any sticky ARP entries or anything fancy like this. You can just, in real time, just replace ARP entries in the ARP cache. Also, if you start flooding the camera with a high amount of network packages, like I did the test with some ARP requests, then you will get to a limit of around 100 packets per second before the network stack of the camera completely dies. Okay, yeah, one could say it's an embedded device. It's not made for like handling network traffic, but also if I got a 6K camera, it should be possible to process more than 100 packets per second. Oh, by the way, I was speaking about IPv6. Some funny thing we figured out, if you put this camera in a network which is IPv6 enabled, the network stack immediately dies. So I guess this is because it can't probably handle all the multicast traffic, but I'm not quite sure. But I just figured out, okay, the camera is not working, so you better should disable IPv6. So there's nothing fancy here, nothing new. So we moved on to the next upper layer, which is the TCP/IP. TCP/IP is used for all further communications. I don't think the camera even implements like an UDP stack. Also, when speaking about TCP, one had to check if it's possible to terminate established connections. This is also easily doable via sending some TCP resets. You just have to hit the right window, which also isn't that hard because of the crappy TCP stack. So there is no window changing in size or anything fancy like that. Okay, remember the last point. We will come back to this in the end. So, okay, that's so far from the network side. There's nothing fancy. It uses Ethernet and TCP/IP. Not very well implemented, but yeah, it's kind of working most of the time. So let's have a look at the communication modes. The camera got 4 so-called communication modes, which you can configure over the menu on the back of the camera. Those are, okay, you got some FTP upload mode. You got a DLNA mode. I will get into this points in detail in a second. You also got a built-in web server, and you got a mode that is called EOS utility mode. We will see what hides behind that later on. Okay, so first the FTP upload mode. This is nothing really spectacular. It's just the camera speaking FTP. So you configure and target FTP server on the back of the camera, which is kind of a real pain because you have to dial in all the numbers via the dial on the back, and you just got a few buttons. So yeah, it's hard to configure your target server and the credentials on the camera if you try to use secure passwords. Once you get all this configured on the camera, and you got this network mode enabled, and take some photos. The photos are immediately uploaded to the FTP server. Okay, yeah, that might come in handy for some photographer who just wants to upload images directly to the cloud. This is where images goes these days. Okay, so the downside with the FTP upload mode is, FTP is clear text. So once you get your hands on the data, you can easily extract all the credentials as well as the complete data transmission. So uploaded pictures can be extracted from a network dump. So if you are able to sniff the data traffic of the camera in this communication mode, you will get all the images as well as all the credentials for the FTP server. Okay, I just got this pointed out here a little bit, so for those of you who've never extracted something from an FTP stream, or let's say from an TCP connection in general, there is one nice little tool which is called TCP flow. You just call it with a network dump as argument, and it will extract all the TCP sessions that are in this network trace. So once you get the TCP sessions extracted, you can call some tool like Foremost, which just does like data recovery. So it looks for images in this data stream and just throw them out as JPEGs. And afterwards, you get all the images that were transferred over the network. So also, this is nothing fancy here. It's just for completeness sake. There is an FTP upload mode. If you use that mode, be aware FTP is unencrypted, and everyone who sees your data traffic is able to extract the credentials as well as the images. So, okay. Let's move on to the next mode, the so-called DLNA. DLNA stands for Digital Living Network Alliance, which is an alliance of mostly vendors who defined some specs for exchanging media files. First, the spec says, okay, devices use UPnP for discovering each other. So that also means once the camera is in this mode, it starts screaming UPnP against some multicast address. So we will easily find the camera in this network mode. Then, what the hell? Then DLNA also defines guidelines for file formats, encodings, and resolution. So maybe if your TV is DLNA compliant in any way, it supports some specified file formats, let's say like JPEG or like MPEG files, and also in specific resolutions. And afterwards, DLNA also defines the access mode to get to those media files, which is in this case HTML and HTTP and XML. So in this mode, the camera fires up like a web server, and on that web server are some XML files which just describe, okay, dear DLNA ready device, you can find the file listing within this XML file, or I got some nice little pictures for you. Okay, so again, the cons with this network mode is DLNA got no authentication at all. So there isn't any authentication defined. The authentication is being able to speak to the device. Also, there are no restrictions in case of who can see which pictures, or which pictures are seen anyway, or who is able to download those pictures. So once you get the camera in this network mode connected and you're able to speak to the camera, you can download all images. You just need a valid DLNA client, and as DLNA is using HTTP and XML, also your browser could be a DLNA client or somebody else's browser. So in this mode, it's also not hard to get your fingers on the footage. You just have to browse to the camera and download the images you like. Okay, yeah. That's kind of boring, isn't it? That was the first two network modes, and both are like broken by design. But hey, it's okay. If you're aware of this and if you want to use FTP, just use FTP. So, okay, let's move on to the next mode, which is the built-in web server. Oh yeah, that's always a great idea, especially when it comes to embedded devices. I would say every embedded device should have a built-in web server. So this communication mode is called the WFT server, or sometimes I also say WTF server, which is the wireless file transmitter server mode. I also got some really nice marketing from Canon USA. It says, yeah, use a web browser to capture, view, and download images remotely. So that implies you can also remote control the camera via the built-in web browser. Yeah, that might come in handy. But the question is the web server secure? It uses a browser interface with a lot of AJAX in the background. So again, HTTP and XML. So those two types of, or the HTTP protocol and an XML parser needs to be built in the camera. They are reused all the time. But the embedded web server is only capable of the HTTP GET method. All the other methods are not implemented, not even a head or something like this. So it's just a very small, very stupid web server. Okay. The good news is there is some kind of authentication in this mode. So you first browse to a landing page or a login page, and there is some HTTP basic authentication. Okay, this again is not so good because, again, if you're like in the data flow, if you have your hands on the traffic, you could extract the authentication credentials as well. But okay, this HTTP basic request is actually sent only once on the login page, and afterward a session cookie is used for further authentication. So on the first view, that doesn't look so bad. First, there is authentication, and okay, maybe it's not the best authentication method, but they only use it once, and afterwards there is some other mechanism. So, but here's the downside. That's what the cookie looks like. What could possibly go wrong? Yeah, you're right. It's an 4-byte session ID. By the way, it's more like this number space is all hex. So again, it's more like 2 bytes session ID, which is not that much. So what the fuck? Okay. We've implemented a nice little brute forcer for the session ID just to have a short proof of concept I can show to you. It was implemented in like 6 lines of Python, so real hard work. What it does, it just checks all possible session IDs, and the downside is to check every of those IDs, it takes about 20 minutes. Because again, the web server, which is built in, is kind of not the best one, and it's not that responsive. So every request takes an amount of time, and that's why it ramps up in the end to like 20 minutes to check all session IDs. Okay, I got a short video of this, just to give you an idea what it looks like. Let me see. There we go. Okay, so this is just the little brute forcing script, which is now running against the camera. You see, okay, it got 1,000 IDs checked, and it just runs and keeps trying each session ID against the login page, because the login page is a very good indicator if you successfully figured out the right session ID or not. Because it says, if you come with a session ID that's invalid, it just prompts you to log in again, but if you came with a session ID that is valid, it just redirects you to the main site. Okay, so we just browse to the camera once to see, okay, sorry, dear user, somebody is at the camera, you don't got the right session ID, please go to the login page and log in again, maybe you lost your cookie somehow. But then, we already got the cookie, we just need to put it in there. So we'll type session ID, type the value, B0E, and we submit the cookie change and reloading the page. And afterwards, you see we're successfully authenticated, and this is the nice interface, and now we can remotely control the camera. Okay, so just to give you an idea of how easy it is to break this 2-byte session ID. Okay, so what's possible once you figure out the right ID? Yeah, you got full access to, as you saw in the video and mode, like the live view. You can also download all stored images, or you can set some settings on the camera. Like you can put your name inside the field which is stored in every picture, making you like the author of the picture or the owner. So could come in handy if you want to get some money for pictures which aren't yours. But it says in the exif. Okay, so you serve, we brood. That's the point. The only thing you need to make this attack work is somebody which is authenticated to the web server. So there need to be at least one valid session. Okay, yeah, as I said, you need the camera in the WTF server mode, you need a valid session, and you need some minutes of time just to brute force the session ID. Okay, that was the third communication mode, and just to not bore you, I will jump right into the last mode, the one at least I personally think is the most interesting one because it was a little bit challenging. It wasn't that easy as FTP or the short session ID. Yeah, this is the EOS utility mode, aka, I said aka I want to be root because this is as close to root as you can get on the camera without injecting some custom shellcode. Okay, here's a screenshot of the EOS utility. That's a tool you install on your Windows or Mac PC to remotely control the camera. So you can like download images, you can go into the remote shooting stuff. This is what the remote control of the camera looks like. You got the live view over here, you got some camera controls on the right, and so on. So this is more or less where the attacker wants to go. He wants to be able to see the live view of the camera or to start, or to take some photos or to download the images. So this mode allows you the remote control of every non-manual camera function, which means I can set everything I could set in the menu. I can't turn the lens, or I can't take the lens cap off. That's the only thing I can't do. But everything else is possible with this proprietary mode. Also, I can up and download images, and possibly even more. I'm able to do even more. So I need to put some more time in, but maybe it's also possible to record sound. Like the camera got a built-in microphone. If I can just turn this on remotely, that would be great. By now, the way around is just to start a movie recording and download the movie afterwards, because then also the sound data is saved inside of the movie file. Okay, so let's speak technically about the mode. The EOS utility mode is some marketing name. It uses internally PTP/IP for communication. Maybe some of you have heard about PTP, the picture transfer protocol, which is used on almost every media device these days. Like every camera out there with a network mode or even with a USB port uses PTP. PTP comes from the USB side of the camera, or even if you get some non-iPod MP3 player, they also speak PTP-IP. No, not PTP-IP, I'm sorry, just PTP. The camera just goes a step further and uses PTP over the IP protocol. And also there is some magic discovery happening. Because once you connect the camera to the network and got the right software installed on your computer, there's just a magic pop-up on your software that says, okay, I found some camera, what do you want to do? What is kind of, or a first thought that's a good sign in the network mode, you need an initial camera software pairing. So you need to put the camera in a pairing mode manually via the menu in the back, and then we'll just pop up on your computer and says, oh, I found an uninitialized camera, do you want to pair with this camera now? And then you click on, yeah, okay, go on, might have a screenshot somewhere. And then the computer or your instance of the ES utility on your computer is pairing with the camera. So initially I thought there is some authentication data exchange, which would make sense at this point of the step, because if you got an initial pairing, you should exchange real hard authentication data. So, yeah, the camera must be put into this mode manually, so you can't do this remotely. And also the camera signals the need for pairing via multicast DNS. So this looks like this. That's just a multicast DNS packet sniffed from the camera, and it says somewhere in here, server canon.com, and it's a Canon digital camera. And also there is a magic field, the tid.canon.com, which is all zeros, a one, and all Fs if the camera is in the pairing state. So this is quite easy detectable. Like multicast DNS can be received everywhere in the network because it's sent to broadcast address. And so once you find the camera in your network sending this magic string, you know, okay, now I'm ready to go, I can just start pairing with the camera. Yeah, this is how the utility looks. If it detects one of these multicast DNS packages, it will just pop up and display you the name of the camera, the MAC address, and the IP address. Okay, afterwards, the client software connects to the camera, in this case via PTP-IP, to initialize the exchange of authentication material. You get an authentication field inside of PTP-IP, which is used to transmit the authentication data you want to use. And the authentication in the peering state of the camera is successfully, regardless of the credentials. They're just saved and stored somewhere on the camera. The authentication data is named here, which should be the host name and some magic GUID. Okay, let's dig a little bit deeper into this magic protocol, the PTP-IP, which somehow feels like USB over IP, because it's just the original picture transfer protocol, which was designed for use on USB, but in this case, it's just used over TCP. So you got all some nice little small TCP packages, because packages on the USB bus doesn't get that big maximum size. So you will have no problem with TCP in the case. Okay, so PTP-IP stands for Picture Transfer Protocol over Internet Protocol. It's specified in an ISO, and it's standardized by the International Imaging Industry Association. So again, some companies sitting together just throwing out some specs. The packet format is quite easy. It's just a wrapper for the PTP protocol, and it adds two fields, which is a length field and a type field. And afterwards, then just follows the PTP data. This is just a screenshot of the layering, so you got the PTP on top, and then you got different packet types, which came from the PTP-IP type field, and then again you got TCP-IP and your network layer below. There is one interesting packet type in the PTP-IP specification, which is the PTP-IP init command request. So this is more or less where you start your PTP-IP connection. This is the initial packet you send to the camera for authenticating yourself or for opening PTP-IP session. And this command includes the authentication data, which is a 16-byte GUID and a hostname string. Okay, when I first saw this, I thought, oh wow, this looks really secure. They got like a hostname string and a 16-byte secret. That would be hard to brute force. Yeah, this is what the packet looks in hex. So you got the packet length in front. You got the packet type afterwards, which in this case is just a 1 for the init command request. Then you got the GUID, this blue string, which is your secret you shared with the camera. Afterwards, you got the host name, which in this case is just a string server encoded in UTF-16. And yeah, afterwards, you got some trailer, which just says, okay, this packet is finished here. Okay, remember the blue string for a second, because we will need this again. Okay, so let's speak a little bit of the attack against this network mode. So obviously, you have to somehow bypass the authentication. It's not as easy as it might seem, because you have seen the authentication data is 16-byte long. But yeah, after investigating the case a little bit, the host name for first is easily discoverable if you use a Windows or a Mac PC, because in the default settings, they just spam their host name all over the network. So you just have to listen for a while in the network, and you see all the hosts that are connected to the network, including their host names. So given that the camera is in an environment where it was peered initially, you could imagine that also the host is present in the network. So you just have to try all the host names you see in the network. Then also the GUID, which after some looking and searching, I figured out is not stored on your client software, as one would imagine, because you got this initial pairing and both exchange credentials, so they should both store the credentials locally. But it's not stored on the host side, it's only stored on the camera, and once the camera connects to a network in the EOS utility mode, it just starts broadcasting the GUID or somehow obfuscated GUID over UPnP again. So connecting to the network, just listening to the multicast traffic, and you're fine again. As you can see, this is one of the packages from a paired camera, and you now got the magic string, the tid.canon.com, isn't all zeros, a one, and all f's, but in this case, it just looks like some random string. But after comparing a network trace from the Canon EOS utility software, where I just put out the identification string. You remember the blue string from some slides ago? I saw that the last part of both strings match. So there was no good obfuscation. They tried to hide it, but not good enough. So I just threw out some other Python code, and once you put this little nice string inside the code and do some magic, afterwards, again, the same blue string as seen in the init command request some slides ago will pop out. Okay, so next thing after getting the authentication data is to actually connect to the camera. But there is, again, one downside of this communication mode. It only allows one connection in parallel. So if there is a client already connected, we need to disconnect this client to make the slot free so we're able to connect to the camera. As I mentioned in the beginning, TCP reset attacks are just working fine. You have really big TCP frame. The frame doesn't change in length. The stack is really lazy, so you don't have to worry about most of the things making TCP reset hard to do. You can just send out a few TCP reset packages, maybe not more than 100 per second, because then the network stack dies. But again, this also disconnects the user. So you could go the easy way or the hard way. Okay, so, and now we're almost finished. We got a whole attack path. So first, we just listen for the camera to broadcast the authentication data via multicast DNS. Then we just need to deobfuscate the authentication data. So we got the right GUID string to authenticate with the camera. Then we need to disconnect, probably connected client, and afterwards connect via PTP/IP and have some fun. While implementing this attack, I figured out the hard part wasn't to listen for the camera or deobfuscate the authentication data. The hard part in this attack actually was to find a library which is capable of proper PTP/IP handling. Because, as I said before, PTP/IP is a nice protocol standardized by some vendors, and it's loaded with vendor proprietary extensions. So you get very little default stuff you can do in the protocol, and you get a lot of vendor proprietary stuff. And finding a library which is able to do the stuff really was the hard part. Okay, so I got a little demo on this as well. This time it's not only a movie, but I'm trying to do this live here. Okay, so I just launched up the tool. The tool now starts listening for multicast DNS sent from the camera. I will now just turn on the camera, and it will need some seconds to connect to the waveLAN to get an IP address via DHCP, and then it starts broadcasting the secret session identifier. Okay, there we go. You see the camera was found. We got an IP address of the camera. We also got the GUID deobfuscated. And afterwards, I used the libgphoto2 to connect to the camera. And what we can do now is first just read out all the configuration of the camera. So you see, for example, which lens is attached. I have no clue what's wrong with the presenter. Okay, you also see the battery level and all that stuff. Yeah, I'm sorry for this. You also see the dialed-in aperture, and you see which camera model it is, and all that stuff. Okay, so the next thing is, okay, I was too slow, talking too much, showing too less. Yeah, okay, we're connected again. And, come on, after getting the configuration, we can just get a file listing of the camera and then start downloading the files that are stored on the camera. And you can see here what I was drinking for breakfast. And okay, the waveline is kind of slow, or the images are really, really big. Come on. What the hell? Yeah. Oh, wow. Okay. So you see, I've took a picture while the keynote was happening in the other room, and yeah, imagine that could be your footage if you're a professional photographer and using this kind of communication mode with the camera. What the hell? Okay, but it even gets better. We not only can download all the taken pictures, we can also get a more or less live stream from the camera. And we've successfully put the camera into a surveillance device. Okay, so what does this mean? If some photographer using an unsecured network, like your hotel's waveLAN or the hotspot in the next Starbucks or some other network, which isn't very unlikely, just think about some big event, then almost anybody with just a little bit of knowledge in the same network, is able to download images from the camera, and in some communication modes, he's even able to do more nasty stuff, like start the recording of a video, get all the audio out of the video. So this camera really is a surveillance device, if you like to. Okay, this brings me to the direction of the end of the presentation. Which are the countermeasures? What can you do to protect yourself from somebody else stealing your pictures? There is not much to do, because you can just use the network modes, the communication modes, or don't use them. And the only thing you can do is enable functionality only in trusted networks. And if you use waveLAN, make sure your waveLAN is encrypted properly. and also make sure it's not Starbucks waveLAN from around the corner. Okay, the conclusions. As those cameras get bigger and bigger and more expensive, they also get more and more networking capabilities. So including some full-blown IP stacks. Hopefully we will see an IPv6 stack in the future as well. So once more, this brings some attack possibilities to the devices that you have not thought of before. So who have thought of doing a TCP reset attack against a DSLR? I don't think there are a lot of you out there. And it also shows that these devices are implemented without security in mind at all, or without too much security in mind. Yeah, they at least try to implement authentication in 2 or 4 communication modes. They failed, but anyways, they at least try to. Okay, so before I come to the end, let's see what are the next steps. So Canon also recently released a new consumer-grade DSLR, the EOS 60. This also features a built-in wireless access point. So it even gets better. And this built-in access point is for your little nice iDevice or your Android device connecting to the camera via the built-in hotspot, and then do some nasty stuff with some communication protocols I need to figure out. If I need to bet, I would bet it's HTTP and XML again, because those two are already implemented in the camera. And also, Canon put out a new series of 4K camcorder just last week, I think, the X820 and X825. And those two also feature some network modes. It's amazing. I've read Canon USA, and they advertise them with, oh yeah, direct movie upload to YouTube or Facebook. So yeah, all your footage to the cloud. It's amazing. I haven't had a chance to take a look on either the 60 or one of those two guys, but if, by the way, does anybody owns an EOS 60? Nobody? Ah, too bad. I just want to put my fingers on, and all I need is a network trace. So maybe you erase your pictures before, but I won't break the camera. So I would be happy if somebody volunteers and shows up with an 60, but yeah, until now that hasn't happened. But these are the next steps, and also quite interesting if I will hear something from Canon in the future. So I tried to get in contact with them before giving the talk, before releasing this publicly, but they got no cert. I haven't found anybody who wanted to listen to me when I tried to explain the attacks to Canon. So it's not that easy to get in contact with somebody who can help me out. Okay, so there is never time enough. Thank you for yours. And are there any questions? I think we got around 10 minutes left for questions.
We have some time for questions.
Yeah.
So, any questions for Daniel? At the back.
So you've got all these stacks, and a lot of the protocols only allow one user at a time.
Sorry, this is not loud enough. I can't understand you.
Okay,
yeah.
That's much better. Okay,
way better.
So you've got these protocols, they only allow one user at a time, but you've got these nice discovery protocols. How easy would it be to start a man-in-the-middle attack? So the legitimate client thinks he's talking to the camera, and the camera thinks he's talking to the legitimate client, but in fact they're all speaking to you.
Yeah, of course, one could do such a thing. Getting man in the middle position is quite easy, as this camera is highly responsive to ARP spoofing. So it just takes a snip of a tool and you're in a layer 2 man in the middle, and then it depends on which network mode you're in. You could do an FTP man in the middle, but you don't need to. Just need to get the network done. I could think of also an PTP IP man in the middle, if you want to do that. That could also be possible. They are just TCP-based protocols. To write a small proxy for those protocols is no problem. So, because in the default, you just need to ship all the data through and just turn around the bits you just want to turn on or off. So yeah, that should be absolutely doable.
Okay, great, thanks.
Okay. Any more questions? Down there, two. Oh.
Hi. I have a question. I was wondering, would it be very difficult to inject other pictures into the camera for the stream? And if so, what would that mean for news gathering organizations?
To upload some images to the camera?
From your own.
Yeah, that's also possible in the EOS utility mode. So in the last of the 4 I presented, there is the capability of uploading data to the camera. And yeah, as I mentioned in the beginning, it would be possible, if you want to build some crazy attack scenario, to point out a photographer you don't like, upload some bad images on his camera, and then just go to the next police officer and point at the cameraman and have them let them have a look at the images. Okay. So there another. Oh yeah.
So I'm wondering if you'd be willing to share the HTTP server fingerprint for the purposes of potentially finding more of these things connected to the internet.
Of course.
Awesome, thank you.
Of course. Okay.
If it con. Yeah. Would it be better if it connected to website first and then post you your photos instead of LAN access?
To what?
Upload the pictures on a website and then you can get them from your computer instead of exchanging via protocols.
Yeah, right. That would be the secure way to do this, to not use the so much brazen network modes of the camera. Is that what you mean?
Yeah.
So,
Talk to a server which is more secure, maybe SSL and stuff like that.
Yeah, right. Okay. More questions?
Would you be willing to share a little bit more about how you got to the surveillance, the remote surveillance mode? Is that based on an existing functionality that users are supposed to have? You mentioned earlier that you could just record a video and then access the video, but is that remote view mode a legitimate thing that you found a way to hijack?
No, it's absolutely legitimate. So the software is also using this feature to give you a preview of the live image, so you can manually focus the lens or anything else before taking the actual picture. So it's just what you do in terms of the camera is you just put the camera into the live mode view. So you open the shutter, you remove the mirror, and then the sensor is just recording images, like for a full HD video, but not saving them. And what I'm doing is I'm just pulling a low resolution preview image of the sensor and getting it over the network and displaying it. And if I'm not in a crowded area and the wavelength connectivity is good and stable, I'm able to do 24 images per second. So I got a real nice video.
Thanks.
Yeah. Okay, more questions?
One more question over there.
There?
Yeah, will it be possible, because I didn't hear that word, will it be possible to actually delete or format the flash card or the everything will be...
I'm saying yes. which means it's possible to format cards inside of the camera. I have not found the proprietary Canon control to trigger the format over PTP-IP, but I think it should be possible. There is a whole bunch of anonymous proprietary functions you can call. I've just not tried all of them. But I bet there is a way to format the card.
Okay.
Okay. Oh.
Hey, you tried responsible disclosure with Canon, and they didn't listen. So now what? What about legal implications and whatever? Do they care?
My point of view is that those bugs are less implementational bugs. Like, I don't need to fill some buffer to get some buffer overflow happening. There are more design issues. Like the camera is designed to work exactly like this. So there, from Canon side of point of view, there is no bug. The camera just does what it's supposed to do. So I'm not quite sure if there is any legal implication, but people who use the camera should be aware of this and should know when to activate the waveLAN and when not to. So that's why I'm standing here in front, even without speaking to Canon.
Okay. I think we're running a bit low on time as well. So I just want to thank you very much, Daniel.
Yeah, thank you.